Alright class, so after you complete the investigation, so you and your partner create your own triangle, and then you calculate the ratio, the side lengths, and then the ratio of the two. You should have noticed that the ratios calculated were the same for each triangle. Okay, so depending on how many places you rounded to and the way we create the triangles, the ratios should have been very close to being the same. So the ratios are the same. And what we can do is use this relationship to figure out the sides and angles of a non-right triangle. So with right triangles, we use the trig ratios, SOHCAHTOA, to figure out unknown sides and angles. With non-right triangles, the first method to figure out unknown sides and angles is called the sine law. So if we consider triangle ABC, okay, so angles capital letters, the sides are lowercase letters. The formula will be that these ratios are equal to each other. Okay. So if we're solving for side, the formula would be A over sine A equals to B over sine B equals to C over sine C. Okay. I got this formula based on the fact that the ratios are the same. Okay, so it doesn't matter if it's this way or they're flipped. Okay, but when they're flipped, it's when we're solving for side, because it's easier to solve when what we're trying to solve for is in the numerator and not the denominator. Whereas if we're solving for angle, all we have to do to keep these ratios the same is to flip all of them. So sine A over A equals to sine B over B equals to sine C over C. So when we're solving for angle, it's easier if what we're trying to solve for, in this case angle, is in the numerator. And again, this formula, we got off the relationship that the ratios are the same. Now, when is the sine law used? So there are two types of non-right triangles in which we'll use the sine law for. So the first type is if we're given two angles and any side, second type of non-triangle that we'll use the sine law for is when we're given a side with its opposite angle and another side. Okay, so this is for non-right triangles. Okay, so again, we use the sine law for non-right triangles, and we use it when two angles and any side are given, or we're given one side and its opposite angle and another side. And then we're going to go for 2 examples to demonstrate how to use the sine law to solve for an unknown side or an unknown angle. I do apologize about the color because it's getting very dark, and if I turn on the light, it's gonna create a shadow. Okay, so I'm just keep the light off, but then it will change colors. So here with the first example, we're finding angle B, and we have to round to the nearest degree. So we have triangle ABC. So what I'm going to do first is I'm going to label the sides. We have side A, side B, side C. Again, we label the sides depending on what its opposite angle is. Okay, so the side will always be the same letter as its opposite angle. So we're looking for angle B. Okay. So we're looking for angle. So I'm going to use the formula sine B over B equals to sine A over A equals to sine C over C. Okay, it's the same thing as the formula we wrote before. I just changed the order, but it's the same thing. They're all equal to each other. I put this one first because we're looking for angle B. Okay, so we're looking for angle B. And what are we given? I'm going to circle the ones that are given with the pink pen. We're given side B, we're given angle A, and we're given side A. So since these 3 are given and we're trying to find angle B, I'm going to use this side of the formula to solve for angle B. So let me sub in what's given. Sine B over side B, which is 3.1, equals to sine of angle A, which is 34 degrees, over side A, which is 1.8 centimeters. Now the unknown's at the top, so let's get rid of the bottom by multiplying both sides by 3.1. This cancels out. I'll get sine B equals to 3.1 times sine of 34 degrees over 1.8. Okay, this is just over 1, so when we multiply fractions, multiply the top together, bottom together. Okay, so back to right triangles. When we're solving for angle, remember we use the sine inverse. So we'll take the sine inverse of whatever this number gives us to get what angle B is. Now with some of your calculators, you cannot enter this in. So what I would do is do a step-by-step so you can figure out the top first, round it to 4 decimal places, divide by 1.8, again round it to 4 decimal places at least, and then whatever you get, take the sine inverse to get angle B. Okay, make sure you try and put in this to your calculator, and if it doesn't give you the answer that I'm about to get, you need to make sure you come see me tomorrow, and then we figure out how to type it in your calculator. But the way I'm going to type it is, show it here, sine inverse of 3.1 sine 34 divided by 1.8. Should be 74 degrees. That's the final answer. Alright, so that's an example of finding angle using sine law. Again, we can use the sine law because it's not a right triangle. We're given a side and its opposite angle and another side. So next, we're going to use the sine law to find side. So for this example, we have to find side C round to the nearest hundredth, or 2 decimal places. So we have triangle ABC. Let's label the sides. This is A, B, C. This time we have to look for side C. So the formula to look for side C will be C over side C. So since we're looking for side, okay, that's going to be on the top. Everything will just be flipped. Equals to A over sine A equals to B over sine B. So I'm trying to find side C. What am I given? Circle it in pink. I'm given angle B, side B, and angle C. So we're not given anything for A. So this time, to find side C, I'm going to set this ratio to this one and solve for C. So let me just sub in what's given. C over sine of 25 degrees equals to side B, which is 4.4, divided by sine of angle B, which is 81 degrees. Unknowns at the top, so we're going to get rid of the bottom by multiplying both sides by sine of 25 degrees. That's going to cancel out, and I'm going to get C equals to whatever this is. So 4.4 divided by sine 81 times sine of 25. And I will get to 2 decimal place, approximately 1.88 centimeters. Okay, this one I don't have to do inverse because we're looking for side, we're not looking for angle. So this is just an example of how to find side using the sine law. Again, we can use the sine law. It's not a right triangle. We're given side B and its opposite angle. And we have another angle. Or we can think of it as we're given 2 angles and 1 side. So there will be cases where we're only given 3 sides and no angles, and that's when we'll use another method to figure out the angles. But we won't cover that until on Monday. Okay, tomorrow we'll just be looking at applications of the sine law. But that's all for the lesson today. Just make sure we get the homework questions done along with the questions from yesterday.